2 more minutes, we'll start the session. Then 10 students can join. Okay, it's already 6 to students. Let students join. Anyway, I'll start the session. I'll share my screen. My slide is visible, right? Yeah, I think so. Okay. Good evening, all. My name is Srihari. I am the teaching assistant for the problem solving session for the course Advances in Welding and Joining Technologies. And the course tutor is Professor Swarup sir. And I'm being the teaching assistant. This is the third live session. Just to give an information, like after each and every live session, we will be uploading the videos in the YouTube. Uh, and also, I think NPTEL is sharing those links to you guys. First and second live session is already shared, and also links are also shared, and I have uploaded in YouTube. And now this is the third live session, which today I will be discussing about this second week assignment of this year's and last year's course, and also I will give few insights about the future technology with respect to the power sources. I mean, it's a laser based. What is the trending topics with respect to this? You'll get to know once I proceed further. And also today, most of the questions are like theory based, and also there is no much conceptual because most of the things are already discussed in class. So today I have very less material to explain. Uh, like this, if it is proceeds in next further future classes also, then I will take few interesting topics related to the welding concepts, and I will after solving these assignments, I will also explain those interesting topics if the if the material is less to explain in the assignment. I hope I made it clear. For today, I will start with this, and also as I said earlier, today this is completely based on theory, theory which is completely explained in the class. Anyway, I will start this session. I think my voice is clear, and also my screen is also visible. Let me know, please, ping in the chat box. Uh, okay, I assume that the slide is visible and my voice is also audible. I will start the session. So, uh, first question: which of the following characteristics answer C? Who answered that? Okay, Vivek, I guess. Yeah. Which of the following characteristics differentiates laser welding from arc welding process? First of all, we'll check the options. C is correct only. Materials for joining need to be electrically conductive in nature. Actually, it should not to be, because in arc welding, to complete the circuit, we need to have a electrically conductive, but it is not the case, right? So they should have mentioned like materials used for joining need not to be electrically conductive in nature. Then that differentiates the laser welding from arc welding. But here it is mentioned like materials used for joining need to be electrical conductive. So obviously, it is not the case. I am again repeating, for arc welding process, uh, they should to close the circuit. The workpiece should also be electrical conductive, so that we can close the circuit. So welding happens, but it is not the case for laser welding, because laser welding, like it light light in laser welding, the work mechanism is completely different. The light is emitted based on the stimulation, uh, and it is focused at a particular point to generate the heat at the point, and if we add this filler material, welding will happen. That is the case. So materials used for joining need to be electrical conductive nature. No, it's not the case, because it and the next option is electromagnetic force is not responsible for material flow. Yeah, electromagnetic force in the sense there is no flow of electrons in the things, so there won't be such kind of electromagnetic forces. Anyway, I will explain the electromagnetic forces in future, in coming questions. So electrical magnetic force is not responsible for material flow. So this is correct only. And the vaporization of material occurs due to a high intensity laser beam. As already discussed in my assignment also, and also sir has explained in detail, in laser beam there will be two types of modes: conduction mode and a keyhole mode. This option, third, is particularly uh, is basically from the keyhole mode, vaporization of the workpiece material occurs due to the high intensity laser beam. Yeah, this is uh, true. And then basically, if suppose I just want to add one point, my handwriting means my mouse using skill is not good. Suppose because of laser beam, high intensity laser beam, initially, because it is concentrated at a particular point, this region will get evaporated. Once it get evaporates, and we are supplying the continuously laser beam, right? Laser beam. So compared to this, actually laser beam diameter will be this one, spot diameter. Once it is directed towards the molten pool, uh, when it is getting melted, its absorption will be more compared to this corresponding liquid metal. So this will get spread and it will get built, so that keyhole is happening, and so we are getting keyhole mode and all. For that the case, the temperature generated should be more than the melting vaporization temperature and all. And once it is generated, because of the vapor pressure, this keyhole is maintained, and surrounding that there will be liquid molten metal. And once it moves forward, this will get filled, this medium is getting filled by the surrounding liquid media, and welding is proceeded further. So vaporization of the workpiece material occurs due to high intensity of laser beam. This is also true. Then due to rapid solidification, hard cracking occurs in joint. This is also true. Why? Because since in arc welding, the arc intensity, again the power densities and all I will show in the next figures. Uh, it is very concentrated at a particular point. Means suppose. Sorry. Okay. So this is the focus region in laser beam. So there will be heat sink in the sense this away from the this molten pool region. This will be at the room temperature, right? So heat sink will be more. But whereas in arc welding or other processes, suppose this is the base plate, this is the arc, and heat sink will be less. So cooling rate will be not that rapid compared to electron beam or laser beam. So because the heat sink is more, it is getting cooled very rapidly. That's why due to this, cooling rate will be very fast. So because of the cooling rate is very fast, there will be rapid solidification, and because of that, hard cracking occurs in the joint. So this is also true. As you said, the option is C. 1C is the answer. Uh, this is also, if you see the search slides, it's like directly mentioned. He also discussed match the following column with column A and with column B in a laser welding process. Increase in voltage. What is the option? Increase in voltage is there. Increase in pulse duration. Increase in laser beam diameter. Increase in, okay, this is very easy. Increase in laser beam diameter. So what happens, the power density will distribute and power density get reduces, right? So shallow soft pointration and wider bit, because if this is the spot diameter and this is the spot diameter, laser spot diameter, this is the thing, and this is the laser spot diameter. Here it is concentrated at a particular point, but if the laser diameter is increasing, heat sink, the laser diameter is increasing means the heat density is reducing for a given constant parameters. So shallow penetration will be less, and we'll get the wider bit. So A3 B3, well, that is the first option we saw. Then we'll check for this increase in voltage. What happens with increase in voltage? Obviously deeper penetration will get in the case of laser, because more number of light laser intensity will be more, so deeper penetration will be A1 B1 and A3 B3, right? Then increase in pulse duration, it is like increase in pulse duration, deeper and wide melting. It's also discussed in, means more time for more time duration of the pulse will be there, means obviously more energy will be there. So because of the deeper and wide welding will be there. So increase in voltage along with pulse duration, with the combination of effect of this and this will get into deeper melting. So what would be the option? uh, yeah, 2B. 2B is the answer. I think this is intermediate only. You guys should have studied this concept. When light energy from a flash lamp is added to the atoms of the lasing material, the majority are excited to higher energy level, uh, a phenomenon known as. Can anyone guess the answer? Actually, these first 10 questions are from last year's assignment questions, and last 10 questions will be this year's assignment question. I am solving the week 2 assignment questions. Can anyone answer for this question? When light energy from a flash lamp is added to the atoms of lasing a material, so from the flash lamp, light energy is added to the lasing material. Because of that, stimulated decay. No, stimulated decay. These decays are all related to some kind of nucleation decay, radioactive decay, and all. This is not no related to uh, laser thing. Actually, the answer is population inversion. Means because of that, it will get into higher energy state. The electrons are excited to higher energy level, as phenomena known as. By definition itself, we should know that it's a population inversion. Population inversion. Yeah. Uh, Initially also, in the electromagnetic force, at that time also I said like I will explain in the coming slide. So which of the following forces influences the material flow in the laser beam welding of metals, right? uh, can Okay, option 1 buoyancy force, 2 surface tension force, 3 electromagnetic force, force due to metal vapor. Can anyone guess what would be the option? Okay. I think it's not discussed. Basically, no, not 1 and 4. Mainly 1 and 2, surface tension force and material flow. It's basically this forces due to metal vapor is maintained to the that keyhole effect, keyhole only. Material flow and all is defined by these buoyancy force, surface tension force, then Lorentz force, arc shear stress force, these forces. Basically, in arc welding and other in general welding, main for generally these forces will be uh, present. Because of that only material flow will inside the pool will happen. Because of that bead geometry is decided. So I will explain buoyancy force, Lorentz force and all. So first of all, buoyancy force. What happens? Suppose this is a weld pool. I think you guys are getting understanding. This is a cross section of a deposited bead, and this is the weld pool. Uh, Suppose if I take point A, B, means A is at the center where arc will be there. Like here the arc will be there. So here the arc will be there. So obviously temperature will be more here. And at the B, other B and all, the temperature will be less. Obvious, right? Because in general, if I take arc welding and all, or in laser or electron beam, it will be a Gaussian distribution. At the center, it will be more. As we go to away from the center towards the solid region, it is getting energy is getting decreased. So obviously, temperature also will get reduced. So if I consider a point A, uh, temperature is more, right? Because of that, we know that as the temperature increases, in general, density will decrease. So density will be less here in point A. In point B, since temperature is comparatively lesser than A, as the temperature is less, density will be more. Guys, if you have any doubt, please put it in the chat box. Then and now only I can explain. So density will be more at point B. Because the density is more, the forces at point B will be downwards because the weight is more here. So it will be more to compared to A. The force is more at the B is the more downwards at B region. Because of that, we'll get buoyancy force. Because of that, we'll get this kind of convection. Means from extreme towards the center, like this flow weld pool convection we'll get. Because of that, this is the weld pool convection. This is mainly this buoyancy force. Mainly, if a buoyancy force is dominating in the given weld region, then we'll get a deep wider. I think this point buoyancy force is understood mainly because of density variation. This kind of uh, flow convection will be there in the weld pool from the extreme towards the center because the density is more here. So from the extreme, so like this, then like this. Lorentz force. Basically, this is electromagnetic force. Electromagnetic force, but in laser beam welding, there is no electromagnetic force, right? But then also in arc welding or in electromagnetic welding, there will be this kind of electromagnetic force. That is nothing but Lorentz force. Because this is like from right hand rule, we know if we have see this is the electric current, and this will be the magnetic field. Based on the magnetic field and electric current, there will be a force also. uh, I think from right hand rule we'll get the directions of the sorry, right hand rule will get the direction of the Lorentz force. This is the electric current. So our so Lorentz force will be towards like this, towards the center. If this is basics only, if you read this like how it is if you follow the welding metallurgy by Sindoku textbook, there he has clearly mentioned about the why, how these directions and all happens. But time constraint, I'm just giving the few insights only, so that if you guys have an interest, you can read further. So because of combined electric and magnetic field, there will be Lorentz force, which is directing towards the center. This is I'm basically explaining for when electrode is negative, means electric current is passing like this. So Lorentz force will be towards center. So because of this, from center, Whirlpool convection will be like from center to away from the molten pool. So here penetration will be more. And also you guys know, right? And if the electrode is negative, penetration will be more. This is the case. Lorentz force and surface tension force. I don't know if you guys are understanding or not. Just I'm giving the insights so that you guys will have an idea about these forces. Basically density, electromagnetic force, and the surface tension force. Because of this difference in the surface tension force, there will be a shear stress gradient will be created. Because of that, there will be a this kind of Whirlpool convection. Okay, we'll understand. Again, A will be at the center and B are at the extreme points. As the temperature at the B, as we know that we understood that at the extreme conditions, we'll have temperature more, right? So temperature is more means surface tension as the temperature is, temperature at A is more and temperature at B is less. As the temperature increases, surface tension force decreases. So because of that, surface tension at A is less and surface tension at B is more. Because of that, a shear stress will be created and molten pool will be outwardly drag. So this is the force. Because of that, we are getting this kind of convection. This is mainly surface tension force. This is mainly because of this we'll get wider beam. This is one kind of surface tension force. And one more thing is the arc shear stress. Because of the arc, there will be a shear stresses generated. Because of the arc pressure, there will be shear stress generated uh, on the surface of the weld pool. Because of that, we'll get this kind of this kind of weld pool convection. This is called arc shear stress. Uh, so in laser, obviously we don't have Lorentz force, and also shear stress force won't be there. So ultimately buoyancy force and surface tension force. So option will be for fourth question, buoyancy force and surface tension force and surface tension force. So option will be 1 2 4D. I think I made it clear. If you guys have any doubt, you can just ping into the chat box. And also I'm telling that in welding metallurgy from Sindoku, he has clearly mentioned. If you guys further want to get clarity about this, you can proceed further. And also again, I want to insist on one more point. This because of this forces only, ultimately the weld bead, how we are going to get whether it is stable bead and whether we get wider bead or penetration is higher, will get based on these forces only, that decides. And also for computational for modeling also, for computational fluid dynamics, we'll apply these forces to get the bead. So 4D is the option. Anyone interested anything? Okay, no. Okay, I'll proceed further. I think this guy you can directly answer. Sorry, because it is directly sir has explained this, right? Which of the following forces are responsible for creating keyhole in electron beam welding? Can anyone answer? 1, 2, 4, right? Lorentz force, again I just now explained. Lorentz force is with respect to keyhole. It nowhere it's related to keyhole. So because of that, Lorentz force won't be there. Electromomentum means because of high voltage, electrons are accelerated towards the base plate, and because of its kinetic energy is converted to heat energy, and it will evaporate the molten pool, and because of that vapors will be created, and this vapor pressure will be maintained, and electron and because of that recoil will be happening. So because of these three things, that keyhole will be formed in the electron beam welding. I think if you guys have enrolled, please chat box. I don't know whether you guys are understanding or not. Only yeah, 5D. Yeah, D is the correct answer. This is directly explained by sir only. Only this one little bit understanding and involvement is required. This is also straightforward. For the sake of understanding, I just get this slide. And also for power density, somewhere it came. I don't know whether I missed it or not. Okay, anyway, I'll explain this. Before going to this question, just if you see this figure, we'll get to know that what will be the power densities with respect to the particular welding. If you see gas welding, arc welding, the power density will be very less. But if you see high energy beam welding like electron beam welding or laser beam welding, the power density is very high, as we know already. Just in the help of heat input versus power density, this figure depicts the for various welding processes. So because of that, we know that penetration will increase, welding uh, welding speed, welding quality welding speed will increase, welding quality in the sense there is no lot damage to the heat effect zone will be less and all, and also but the equipment cost is more, as we know laser and electron beam using more. So if you consider only TIG and electron beam welding, this is the power density variation. See, it in generally in TIG around 10 to the power 6 watt per meter square, something in that range will be there. But in electron beam welding on 10 power 10 range, so we'll get the we'll get the less deeper penetration is less here. But in electron beam, we'll get the deeper penetration. You can see in this figure, right? This is the bead which we got. But in laser gas junction welding, the bead is somewhat this thing. After I think I made it clear. So now we check penetration or keyhole mode welding is characterized by narrow beam weld. Okay, increasing the power density beyond increasing the power density beyond critical value leads to high aspect. Increasing the power beyond critical value leads to increasing high aspect ratio. Yeah, because of power density more power density, it will increase uh, high aspect ratio, and narrow beam will be because of that keyhole mode will be achieved, and so we'll get narrow weld beam. So for sixth one, I think both A and R are correct, and R is the correct explanation of A. Guys, if you have any doubt, you can put it in the chat box. Okay, I think no one has. Okay, I'll proceed further. This is I directly taken this from the Soru Buxler's slides only. Match the column with the column B. Basically, the electrons will be generated and the diameter will be more, electron beam diameter will be more, because of that magnetic focusing lens will be used to focus on the workpiece plane, and with the magnetic deflection coil we can change the position. This is the point, right? And this grid is used to accelerate the electrons. I think sir has explained it clearly. So can you guys answer like okay, no one has to- okay. So magnetic focusing lens means focusing will be happening, and A to deflection will guide means where to weld, in which location and all. Uh, and anode obviously for generation, because of the cathode anode differential electron will be generated and these whole things. Uh, and the grid bias cup is used for acceleration. Therefore B2. So this is the 7D is the option. This is also sir has explained. In electron beam welding process, electrons are generated by heating a negatively charged element up to. By definition, we know that if we heat any filament to a its more than its the thermodynamic emission temperature, uh, electrons will be released. So 8C is the option. In the later slides, I will explain what are the other modes of electron emission. This is one thermal emission temperature. Choose the appropriate option for from the following. Pulse shaping is a laser welding. Yes, pulse shaping, because of the pulse shaping we get optimized penetration depth. Obviously, because we are changing the uh, uh, like peak duration and background duration, something like that. So we will get optimized penetration depth and welding of highly reflective materials. By changing that, we get, yeah, phases of pulse shaping are initiation of welding between two materials and stabilizing the welding between two materials. Yeah, yeah, both A and are correct. Because of this pulse shaping and all, you can control the whatever application we need. Like if you want penetration depth, or like if you are welding for higher high reflective materials like aluminum and all, so pulse shaping is required. So both A and R is the correct explanation of A. I think this I like just now I explained like keyword like that electron momentum, recoil pressure, and electromomentum, recoil pressure, and vapor pressure, right? So based on that only this question is framed. I think if you guys just go through that, you will directly get the answer. Like which of the following statements are correct regarding keyword function in electron beam welding? Impact of high energy electron beam welding on what is? Yeah, it is correct. High energy density electron beam causes the metal to evaporate. Yeah, because of the first once it start evaporating, the keyword will start forming. Due to the high density beam, metal vapor cavity surrounded by a shell of fluid. Yeah, this is also true. Due to the capillary action of the fluid, results in formation of keyhole. Yeah, this is also true. So all statements are true. So 10D is the option 1, 2, 3, 4. So all this is the answer. So from the now this last year's question like assignments of two is solved. Now we are going into the this year, so which you guys are already submitted, right? I think 2 days back. I don't know exact which date. So we'll be discussing about those topics. Which of the following represents the application of laser in manufacturing industry? Utilize it for welding a sheet. Yeah, thin sheets also we can weld, right? With the help of conduction mode, welding it is without density and all. And also, you guys have answered it, right? You can chat, put it in the chat. Oh, very few are in interacting, and other are not. Okay. Vivek has answered it as A, B, C, D. Yeah, yeah, it's correct only. Used as a, yeah, correct. Praveen answered. Okay. Yeah. A, B, C, all these three are the all the four are the correct. Used as a heat source for melting feedstock material in additive manufacturing. In this first class itself, I said, right, in the first session, in the beginning of the session, I said that I will explain about other topics also on this additive manufacturing. Just a brief insights about that. Erase this. Okay. So all three A, B, C, D is the correct answer. So we'll proceed further. If I have time permits, I will give brief insights so that you guys can get motivated, and also you can proceed if you guys have interest in this, because it is a very booming area in India. Also, many IITs also they are working in this metal additive manufacturing and also polymer based additive manufacturing. Means basically it's a 3D printing. Uh, like we'll have substantive. I think you guys have a little bit idea about additive manufacturing. Many IITs are working, and also in foreign universities, very good R&D is happening because of because it has wide variety of applications in automotive, dental, medical applications, and also in aerospace, automotive, and also food industry. It has a very good scope. So lot of research means lot of institutes and also R&D companies are working together to make ca- this technology commercialized so that we can achieve the benefits from this additive manufacturing. I don't know whether you guys know about this or not. I'll just give the brief of it in the coming slides. Once everything is done, okay, let us go fast and so that I can explain, give insights about it. Utilization of feed source are not limited up to basically. Uh, uh, since these assignment questions are like directly theory based, so I wanted to just give the insights about that so that we guys get motivated. If you wish, you can proceed in this direction also in your future studies or your future when you are working. Because this is very booming and also in many IITs, many NITs also, like additive manufacturing MTech courses are also started. So in future it has a very good scope. Utilization of laser as a heat source not limited up to electrically conducting material. Yeah, this is true. Just now we discussed, right? And you guys also answered it, right? Laser output is not electrical in nature, hence it depends on the flow of electron. Yeah, this is also true. So both A and yeah, both A and R are true. Means assertion and reason are true, and R assertion the reason is the correct explanation of assertion. This is also this is also straightforward because pumping source. Here the pumping source is xenon flash pump, right? Because of this, it will excite the neodymium means layering material, and that once it goes to higher energy level, when it comes back, photons are released. This and this will be reflected in the reflector, partially reflecting mirror and the mirror. And once it gets highly directional and wavelength is highly directional, it comes out and we'll focus it with the help of focusing thing, beam delivery thing, and we'll get the laser. So pumping force is like C, yeah, correct. Pumping force xenon flash pump, optical resonator B means and yeah, this is also ends of rod silver coated, yeah, active medium C2, 13C, A3B. I don't know what you texted. You texted C or B. I think answer is C. Let me check. Active medium. Active medium. This. Yeah. Okay. C is the yeah. C is the correct answer. Active medium is like yttrium aluminum garnet, and active center is neodymium. Yeah. C 13C is the answer. Okay. We will proceed further. We don't have time. This is like we know the formula, right? Can you? I think you guys already answered it. Yeah. Let me write the formula. EP into, I could have directly kept the screenshot. Anyway, EP into R, this is frequency, will be given by P average. Okay. P average means average power is given by energy of the pulse into frequency, or this is repetition rate of frequency. So 20 into 10 power 3, this is basically straightforward. Anyhow, 20 into the power 3 into 0.4 into 10 power of minus 3. This thing will just cancel. 20, 0 and point also cancel. So 2 into 4, 8 points. Which of the following process parameters are pertaining to micro laser welding? This is also straightforward. Because acceleration of voltage and voltage of the electron, this and all will comes under electron beam, right? Uh, so 1 and 2 is the correct answer. So D is the option. Yeah, correct. D is the option. Which of the following characters are pertaining to the keyhole mode laser welding? 16 question. Low coupling efficiency, no. High aspect ratio, yeah. B, yeah, correct. Because high aspect ratio will be there. Because in depth direction it will be more compared to the width direction. So high aspect ratio. And high no, low welding is it's the reverse, right? Low welding depth is not the answer, and high welding depth is the answer. So 2 and 4. So 16B is the answer. 60 for 16B is the answer. This is also initially explained, right? In the first question. For the sake of your understanding, just I'm briefing out. Based on the density variation, we'll get the direction of the like the from the extreme to the center in buoyancy force. In Lorentz force, based on the current flow and all, we get the weld connection, current and electromagnetic field. Based on that, we get the Lorentz force. Surface tension, uh, because of that means variation in the surface tension across the weld pool, we'll get the force. And also, if you notice, I forgot to mention one more point. In activated click, this trend will change. Means it will go in. It will be in the reverse direction. B will be less. Sorry, B will be surface tension is less, and A is more. So the trend will change. One second. Yeah, sorry to. So arc shear stress, because of the arc pressure, this arc shear stress will be there. We were in 16th or 17th. 17th. So, which of the following combination of forces affects the material flow in welding? So, first of all, electromagnetic won't be there. So, buoyancy force will be there, and arc force won't be there. Means arc shear force and all it won't be there. Electromagnetic, what it takes 17C. Yeah, C is the correct answer because buoyancy force is there, electromagnetic force won't be there, surface tension force is there. Yeah, so C. Electromagnetic forces also won't be there because it's straightforward. There is no electron flow because of that. Arc welding and all it will be there. Okay, next question. Uh, distortion present in the electron beam weld sample is less compared to other welding process. Electrons is, with a high velocity depends on the surface of the material is transferred to the this anyway this the first sentence is true. Distortion is less compared to other welding process. I will see the reason what they have done. Yeah, correct. B is the answer. Both electrons with high velocity impinge on the surface of the material is transferred to heat and induces maximum amount of weld function with least amount of heat. B is the answer. First of all, we'll understand why it is the correct answer. B is the correct reason. Uh, Least amount of heat. This is the one point. Because of this least amount of point, last class I explained about the residual stresses and distortion generation, right? Uh, so if the and I said that the heat input is the culprit for most of the problems in welding or additive manufacturing in any case. So least amount of heat input. So reason is it true? One more perspective what we can see is if you see here to join the same thickness material, amount of molten material needs to be deposited from GTW is this much, but this is very less in electron beam welding. So obviously heat input amount of heat required to melt the electrode is also reduced. So because of that heat input is less in case of electron beam welding. So B is the answer. If you guys have any doubt, you can ask me. Which of the following forces are responsible for keyhole formation in the electron beam welding? See, if you guys understand this buoyancy, electromagnetic field, this kind of questions can be easily answered. 19, yeah, 19D is the answer. Yeah. Which are the following processes are responsible for keyhole formation in the electron beam welding? Because of vapor pressure and recoil pressure. Yeah, because nowhere buoyancy force comes and surface tension comes. And also gravitation won't come. In gravitational, these things and all in droplet detachment, these things will play a role. But keyhole formation and all, mainly vapor pressure and recoil pressure. And also sir has in his lecture. In electron beam welding process, this is the last question. In electron beam welding process, electrons are generated by heating a filament up to. I, I think one of the question was in the last year's assignment also related to this is thermionic emission temperature. If we heat an element, even in electric bulbs also, this kind of principle you can get. That means if we are heating in bulb also, normal zero bulb also, we raise the temperature because of the resistant heating, because of the resistant uh, recoil pressure. Oh, okay, recoil pressure. Because see, electron momentum means electrons with high speed it will hit the bombard the base plate. Because of that, kinetic energy is converted to heat energy. That is electron momentum. Vapor pressure I explained earlier. Uh, Vapor is created, and it's because of that pressure will be there. So molten pool won't enter into that when the electron beam or laser beam is near. And recoil pressure means it is basically absorbed in electron beam welding, like interaction of electron beam with the material creates a recoil pressure. Uh, because of that, uh, it will helps in the keyhole formation. If I am right now, it's basically generated due to the interaction between the electron and the material. So 19D is the answer. Then okay. In electron beam welding process, electrons are generated by heating a filament up to melting point temperature, recrystallization temperature, thermionic emission temperature. I just now said right, thermionic emission temperature. So this is thermionic emission temperature. What are the other options? We'll see melting point temperature. This is no, there is no point, right? It will get melted. Material will convert into solid to liquid temperature. This is melting point temperature. Can anyone tell what is recrystallization temperature? You guys would have studied in metal forming those concepts. I'll be waiting for you to play 1 minute. Recrystallization temperature. Anyway, you guys get confused if I think answer is recrystallization temperature. As answer is thermionic emission temperature. So basically, recrystallization temperature means once we start heating any particular metal, it will have some grains, right? It will change the grain structure, new grain structures will form, and it will change its behavior. Basically, if you heat a temperature more than recrystallization temperature, and if you work forming, forging, extrusion, wire drawing, or bending, if we heat the metal above the recrystallization temperature, and if we uh, form it, then it is called hot working. If we don't, if the temperature, if we heat the metal or material less than the recrystallization temperature, and if you work on it to produce a metal forming, means any forming or extrusion, forging, other things, uh, it is cold working. I think you guys would have been in your colleges. You would have done forging, right? You will heat the red hot till some particular temperature, and then you hit it with a hammer. Even in roadside also forming while sharpening of the knives and all, they will heat it to some particular temperature, and then they will form it, right? Means apply the compressive pressure. So that is recrystallization temperature. So that recrystallization temperature, if you form, means if you work more than a recrystallization temperature, it's called hot working. If it is less than representation means then it's the cold working. This is the thing. I think if you guys would have studied in farming, right, metal farming and all, and also in forging and all, in lab experiment, you would have seen directly in either in lab or in roadside when someone is doing forging and all. That is that the recrystallization, that is the importance of recrystallization temperature, and many other importance are there. Just relating to the metal form. So proceeding further, uh, this is thermionic emission, right? So generally we know that if we heat a temperature particular more than that, the electrons will be released from that filament or from that material. That is called thermionic emission. But apart from that, there are other emissions also. Field emission, secondary emission. Means if we maintain a high strength of electromagnetic field, the metal from the metallic surface, the electron will be removed. That is called field emission. Here we maintain very high potential difference to generate this field emission. This will be used in some kind of welding techniques. And secondary emission means they, yeah, best example is in arc welding. Suppose if we take metal tungsten, what is it? GMAW, gas metal arc welding. That is called metal ingot gas welding. There will be a gap. Then also electrons will flow, right? That is mainly due to secondary emission. Means uh, generally first electrons will be generated based on either with the thermionic emission or field emission, and then electron gap will be created. Once the gap is created, but this is already conductive gap. That gap will be, is filled by ionized gas, right? And it will be conductive because of the conductive nature. Because of the conductive nature, the electrons will be from the ionized medium. The electrons will be released, and charged particles will be flow from anode to cathode. Basically, uh, how though there is a gap between the electrode and the metal, how arc is generated, right? Initially, what happens is in general, in some kind of if you take uh, GMAW in kind of automatic based, generally initially the electrode will touch, so it will get conductive. Electricity will pass, so that electrons will flow. After that, suddenly we'll retract it back. Because of that, already this is conductive. Because of this, so the surrounding ionized gas will be getting conductive. Means it will get charged. And again, because of that potential difference, the electrons will flow from this to that, or here to here, based on the polarity. So that is the how arc is generated initially. First, we'll make it conductive. Once it is conductive, the temperature of the ionized gases, shielding gases will increase, and it forms ionized medium where charged particles will be generated, and it will flow from positive to negative, negative to positive, and because of that, welding will happen. This is the secondary emission. I hope I made it clear. Yeah. I said that I'll just give few insights to the additive manufacturing, right? Because in this question, it was like, which of the following represents the application of laser in manufacturing industry? Use of heat source for melting feedstock material in additive manufacturing. I'll just give few insights. I don't know whether you guys are understanding or not. Just you guys get to know how welding and laser beam, electron beam welding, arc beam welding used in metal additive manufacturing welding, where lot of scope is there. Basically additive manufacturing in the sense will generally, suppose uh, if I want to make a sphere, generally what we'll do, with the help of, we'll take a cube, we'll hit it with, if it is forging means in the between the dies we'll compress it, and we'll get the from the cube to some kind of sphere. uh, so some kind of sphere, right? With the help of, if it is forging, we'll hit it and we'll get the sphere. But and also in casting, if we melt it and if we pour it in a die, based on the shape, we'll get the component. Or in subtractive means, if we machine it, if we remove the excessive material, subtractive this thing, we'll remove the material and we'll get the shape of the component. So these are traditional conventional things, right? There is one more. This is additive manufacturing means. we'll add the material. Initially there won't be anything based on the CAD model. I don't know guys, or if you guys get confused, you can stop me at any point. Basically, though in subtractive, we'll remove the material with the help of turning or other upper milling, other options, and we'll get the required shape. And in case if you want any hole in the block, with the help of drilling, we'll remove the material and we'll get the hole in the block like that. But in case of additive manufacturing, we'll add the layer by layer. Means it's termed as layer by layer deposition. If you want to deposit this kind of black in additive manufacturing, what you will do, first I will generate the CAD model in some softwares, then I will generate the tool path with the help of heat source. Consider with the help of heat source and filler metal, according to the CAD model in slice information, I will deposit the component layer by layer to get this kind of block. Sorry for my poor drawing skills. Next time I will try to use pen and touchpad. Then it will be better. So that is additive manufacturing. Means we'll add layer. If you guys have any query, you can ask. Okay. Any question? So basically, we'll add layer by layer. So material will be joined in layer by layer. As in conventional, we either will remove or will apply the some kind of force, or will melt the material and we'll get the component like in casting. But here we'll add layer by layer. Initially, there won't be any component itself. Based on the slice information, there will be a filament, means supply of raw material, and raw material will be melted and will generate the CAD, will generate the required component. Layer by layer will be deposition. This is called additive manufacturing. And I don't know, it will be like if you guys did any course about this, it will be easy to understand. So in the question, we are using liquid, laser power source, right? Yeah, because in this you can see selective laser sintering, even selective laser melting, and other things also. We use laser as a power source to melt the powder material to generate the CAD shape based on the CAD model. To generate the model required component based on the CAD model. And also we can use electron beam welding also. Electron beam also is used to melt the powder or else some wire material to get the material. And also the other polymer based also is there, fused deposition molding, even vat polymerization liquid. Here the material will be liquid based on the heat. Here the liquid will cooled and it will get into a solid thing, and CAD will get the 3D component. I don't know whether I am complicating things or not. I just wanted to give the few insights about this process also. And sheet stacking technologies means here we are stacking the one by one sheets, and after stacking if we get the desired shape, we'll bond it with the help of adhesive bonding. You guys studied right in this course, so adhesive bonding will be used. And also even for cutting those things we'll use laser thing to cut the sheets. Initially there will be a plain sheet, we'll stack it and we'll cut it as per the required dimension. We'll get the required shape, and there will be various joining technology, means various bonding mechanisms to the sheet stacking technologies. So these are the things. I don't want to exit further. Just I will just show you some schematics. This is the powder based selective laser sintering (SLS) process. Means initially this will be the feed cartridges. I will supply the powder. Okay, I will supply the powder. So initially there will be a powder on this powder bed, right? And this CO2 laser based studied, right? This laser will be sent to here through these mirrors. So once the laser is focused, it will get melted. So it will get melted and will get one layer of slice information is replicated here. So will it get solidified. Again after this, again one more layer of powder is powder is spreaded on the this build part platform. Again with the help of laser, it will melt based on these things and we'll get the CAD model. This is one kind of SLS. I am especially explaining about the metal additive manufacturing thing. And also if we use a laser beam or electron beam or any other beam or arc itself, and if I supply the powder, It's and we supply the powder, and with the help of arc it's getting melted, and we are see, this is the first layer, this is the second layer, this is the third layer. Now we are depositing third layer. So based on the CAD model we are depositing, as I said, cube, right? Here the requirement is cube. So first layer is deposited, second layer is also deposited, means the powder is fed, and with the help of laser beam it is melted, and as per our CAD model information we are depositing. This is a direct energy deposition thing. And also GMAW based, you understood, you guys, generally there will be a base plate. Okay, size, yeah, yeah, this is a good question. uh, Size is yeah, this is very slow process. Actually it's a very good question. See, the problem is uh, if we generally in direct energy based also we'll have powder based, and also we have wire or additive manufacturing. For if this powder based, yeah, though it is slow, but very complicated shapes can be generated based on the CAD model. That is the thing. So it is slow. Yeah, I do agree. But in this GMAW based is there, no. Here we are using wire and deposit. As we know, the deposition rate we can achieve is like 6 to 10 kg per hour. That much amount of deposition rate can be achieved here. So here the deposition rate is high, but either complicated shapes cannot be generated. Okay, to that question I answered. But generally, what happens? This is a base plate, and uh, I need to join here. So based on the arc, it is joining, right? So that is normal welding. But what happens here is this: there will be substrate. So one substrate, and above that I will deposit the layers like this. This is a cross section I'm showing. As per required thing I'm getting the shape. If you can see here, these are like one layer, two layer, number of layers are deposited, like this is the first layer, second layer, third layer, and all. This is GMW based. uh, this is also kind of DED thing, but here we are using electric arc, welding arc. Here we are using laser beam. Even sometimes the electron beam is also used instead of powder stream. Even can supply wire also, that is there. So these kind of few welding processes, like few energy source, and with the help of feedstock, we are with the, based on the CAD model information, we are depositing the component. I think I just gave. I don't know you guys understood or not. I just gave little idea about that.